In this video, we'll talk about production. So we've moved on into chapter 6. We're skipping chapter 5, which is about uncertainty in consumer behavior, and we'll revisit that after our discussion of the producer once we start getting into behavior and game theory. So chapter 6 is on production, and we're going to introduce a production function or production technology. A production function or production technology just tells you if you have two inputs of production, how much can you produce? So this is really very similar to a utility function. And again, we're going to stick for the most part with the two good, or in this case, two input world, broadly defining labor and capital as our inputs. So when we do this, we're going to distinguish between the short run and the long run. And the distinction is that in the short run, at least one of our inputs will be fixed, so either capital or labor. Usually we think of capital as being the input that's fixed, like land or machines that you have, and labor as our variable input, but either one could be fixed or both in the short run. And then in the long run, all inputs are variable. Right, so again, we're going to be really paralleling, I guess, kind of chapter 3, which talks about optimization for the consumer, and we're working on now optimization for the producer's side. So again, the general idea here is suppose we know some sort of production technology that we have. If we talked about improvements in production technology, those would show up in the production function. So we might have production functions similar to what we looked at in the last chapter, something like k to the 1/2, L to the 1/2. Or we could also talk about perfect complements and substitutes in production as well, which we will. So suppose we know this production function or production technology. Just a couple of calculations we can apply. One would be the average product. And if we're assuming that capital is fixed, for example, we might want to take the average product of labor. The average product of labor, if we have our total amount of output and we divide by how much labor we use to get that output, that tells us the average product of labor. We could do this for capital too, but if we're assuming capital is fixed, then there's no point in that. So for now, we're just assuming that labor is variable and capital is fixed. We can calculate the average product of labor. We can also calculate the marginal product of labor, which tells us if we add an additional unit of labor, how much more additional output will we get? Right, just like in chapter 3, when we started talking about marginal utilities, here we're doing marginal products. We can find the marginal products as the derivative of our production function with respect to that input. So the marginal product of labor is the derivative of the production function with respect to L. Right, so here suppose we have this production function specified. So this gives us our total product. We're going to keep capital fixed and vary labor. So this shows us as you increase labor, how does output change? So the relationship then between the average and total product, the average is this lighter blue curve. At any point, we can divide our output by our labor and get the average product of labor. So let's look at point B here. If we had 60 output using 3 labor, our average product of labor should be 20. And we see that's right. Okay, over here we had 112 output. We used 8 labor. 112 divided by 8 is 14. And we got about 14 as our average product of labor. Right, what about the marginal product? The marginal product, how fast does the total product change when we change labor, or in other words, the slope? So things to remember here. When is our marginal product curve going to be at its maximum or its highest point? When is the slope of the total product curve the highest? It's at this steepest point. So this is saying the steepest point here is right about B, meaning that marginal product is at a maximum. And then we have this idea of diminishing total returns, which says that eventually at some point, as long as one of the inputs is fixed, so as long as capital is fixed, if we keep adding labor, eventually total output is going to start going down. And so the reason for that, again, if we talk about keeping capital fixed, suppose we just have a factory or a plot of land, we keep adding more workers, we get more output. Eventually it's going to get too crowded, too many bodies getting in each other's way, so total product actually starts going down. Then we can see marginal product is negative for that range. What's it saying? If we add another unit of labor, we're going to have less total product here than we did before. So marginal product is negative. All right, so hopefully you're kind of familiar calculating the marginals from back in chapter 3. We're going to use the same derivative rules. Those functions are going to look very similar. We have the multiplicative cases and sometimes Cobb-Douglas if the exponents add up to 1. And then we have perfect substitutes, which are going to produce linear functions, and we have perfect complements. Okay, so these were just sort of two definitions, average and marginal product of labor. All right, we talked a little bit about the law of diminishing returns. The law of diminishing returns means that as long as one of the inputs, in this case capital, is fixed, ultimately we're going to start getting this decrease in overall output. Right, so it might be different for different production technologies, different production functions or products. When does total product start decreasing if you hire too many workers? But the law just states that eventually it will.